Tonight, we're going to follow something that seems to vanish. Not slowly, not dramatically, but quietly. So quietly that we almost never question it. Because every day, energy appears to disappear. A hot cup of tea cools down. A beam of light fades into darkness. A moving object comes to rest. And each time, it feels like something has been lost. Something that was once there is no longer there. But physics tells us something very different. It tells us that energy never disappears, that it is never destroyed, that it does not simply fade away into nothing. And yet, when you watch it closely, it certainly looks like it does. So tonight, we're going to ask a deeper question. Not just where energy goes when it disappears, but whether it ever truly goes anywhere at all. Because what if energy doesn't travel the way we imagine? What if it doesn't move like an object, or flow like a substance, but only appears to shift, because something deeper is changing beneath it? So, as the world around you grows quiet, let your thoughts slow down, and let's follow something that seems to vanish, but never really does. Energy does not leave in a dramatic way. It doesn't erupt or vanish with a clear boundary you can point to. Instead, it fades quietly, almost politely, as if it slips past your attention rather than confronting it. You experience it every day without thinking about it. A cup of tea begins warm in your hands, almost comforting in its presence. You can feel the heat spreading into your skin, radiating outward into the air. For a brief moment, it feels like something real and contained, something you could almost hold on to. But as time passes, that warmth begins to soften, the edges blur, the sensation weakens. And eventually, the cup feels no different from the room around it. If you focus only on what you can feel, it is as if the energy has simply disappeared. The same quiet disappearance happens with motion. A ball rolls across a surface, carrying with it a clear sense of movement and direction. You can follow it, predict it, almost feel the energy in its motion as it travels forward, but gradually, it slows. The movement becomes less certain, less pronounced, until it finally stops. In that final moment, there is no visible trace of what was there before. The motion is gone. And again, it feels like something has been lost, as if the energy that once defined the system has drained away into nothing. But this feeling, as natural as it is deeply misleading. Physics tells us that in both cases, nothing has actually disappeared. The warmth of the tea has not been destroyed. It has spread into the surrounding air, into the walls, into everything nearby. The motion of the ball has not been erased. It has been transformed into microscopic vibrations, tiny movements within the surface it rolled across, too small and too scattered for us to notice. The energy is still present, still accounted for, still following the same rules it always has. What has changed is not the amount of energy, but its visibility. It has moved from something concentrated and noticeable into something diffuse and hidden. And once energy becomes spread out enough, it stops feeling like something that exists at all. It blends into the background, into the quiet noise of the world, until our senses no longer register it. This is the moment where disappearance is born, not from the loss of energy, but from the loss of structure. And that distinction, subtle as it seems, is the beginning of a much deeper shift in how we understand what energy really is. If energy does not move like an object, then something else must be happening when it appears to travel. What actually changes is not the presence of some invisible substance, but the arrangement of activity within a system. This idea is easy to miss, because our intuition is built on objects. We are used to thinking in terms of things that go from one place to another. A ball moves, a drop of water falls. A piece of dust drifts through the air. So when we talk about energy, we instinctively try to fit it into that same picture. But energy does not behave like an object you can isolate and follow. Instead, it behaves like a pattern of relationships between parts of a system. When a hot object cools, nothing leaves it in the form of a visible entity. What changes is the distribution of motion among its particles. The faster motions spread into slower ones, gradually evening out. The energy has not traveled as a thing. The pattern has simply rearranged itself across a larger space. The same idea applies to motion. When a moving object slows down, we might say it loses energy, but nothing has been removed in the way we remove a physical object. The organized motion of the object becomes disorganized motion in its surroundings. What was once a clear, directional pattern becomes a scattered, microscopic one. And this shift from organized to disorganized is one of the most important ideas in understanding where energy goes. Because organized energy is easy to notice. It creates visible motion, strong heat, clear effects. Disorganized energy, on the other hand, blends into the background. It becomes part of the countless tiny interactions that are always happening but rarely felt. This is why disappearance feels so convincing. When energy spreads out and loses its structure, it stops standing out. It becomes indistinguishable from everything else. And once that happens, our minds treat it as if it is no longer there. But from a physical perspective, nothing has been lost. The total energy remains exactly the same. Only its arrangement has changed. You can think of it like a drop of ink in water. At first, the ink is concentrated, clearly visible as a distinct shape. But over time, it spreads out, dissolving into the water until it is no longer distinguishable. At that point, it feels like the ink has disappeared. But it hasn't. It has simply become evenly distributed. Energy behaves in a similar way, not as a substance dissolving, but as a structure that spreads until it can no longer be picked out from its surroundings. And once you see that, the question of where energy goes begins to shift again. Because if energy never truly leaves, and only changes how it is arranged, then the real mystery is not disappearance. It is why energy ever appears as something structured and noticeable in the first place. At some point, energy does not just spread out. It crosses a threshold. Not a sharp boundary you can measure, but a quiet transition in how it is experienced. A point where it stops being something noticeable and becomes something that simply blends into everything else. This is the moment where energy feels like it has disappeared, even though, in physical terms, nothing has been lost at all. When energy is concentrated, it creates contrast. It stands out against its surroundings. A hot object in a cooler room is easy to detect because it disrupts the balance. A moving object is easy to track because it differs from what is still. In both cases, energy expresses itself through difference, through structure, through a kind of imbalance that makes it visible to the senses. But as energy spreads, that contrast begins to fade. The temperature difference becomes smaller. The motion becomes less organized. The patterns that once made the energy obvious start to dissolve into the background of countless tiny interactions. And once that difference becomes small enough, the system reaches a state where nothing stands out anymore. Everything feels the same. In that state, energy has not vanished. It has become uniform. This uniformity is what makes it invisible. Not because it cannot be measured, but because there is no longer any clear reference point, no edge, no direction, no structure that separates one part of the system from another. The energy is still present, still moving, still interacting at the smallest scales, but it no longer produces anything that the mind recognizes as change. This is why a room at a stable temperature feels still, even though the molecules inside it are in constant motion. It is why an object at rest seems inactive, even though energy is still present in the microscopic behavior of its particles. The absence we feel is not the absence of energy, but the absence of difference. And this leads to a deeper realization. What we experience as energy is not the total amount that exists, but the part of it that creates noticeable change. The part that forms patterns, gradients, movement, imbalance. Once those features fade, energy does not leave. It simply becomes indistinguishable from the rest of reality. It becomes part of the quiet baseline that is always there. And once energy reaches that baseline, something interesting happens to our original question. Because asking where energy goes when it disappears starts to feel slightly misplaced. It suggests that energy must travel somewhere else or exit the system entirely. But what we are actually seeing is something much simpler and much stranger at the same time. Energy is not going anywhere. It is becoming everything. At first glance, empty space seems like the perfect example of nothing. No objects, no motion, no visible activity. A vast, silent region where nothing happens and nothing exists. And if energy appears to disappear when it spreads out and loses structure, then empty space should represent the final stage of that process. A place where energy has fully faded away, leaving behind complete stillness. But this is where intuition breaks again. Because according to modern physics, empty space is not empty at all. Even in a region of space where there are no particles, no radiation, no measurable disturbances in the usual sense, something still remains. Not something you can see or touch, not something that forms objects or produces obvious motion, but something more subtle and more fundamental. Fields. Quantum fields are not optional features of the universe. They are always present, everywhere, at every point in space. Even when nothing seems to be happening, these fields do not turn off. They do not disappear. They remain, quietly defining what is possible in that region. And because these fields exist, energy cannot drop to zero in the way we might expect. There is always a lowest possible level of activity, a baseline that cannot be removed. This is sometimes called the ground state, or zero-point energy. But the name can be misleading because it suggests something small or negligible. In reality, it represents something unavoidable. Even in complete emptiness, the fields cannot be perfectly still. They continue to fluctuate, gently, constantly, in ways that are too small and too fast to be noticed directly. These fluctuations are not caused by anything external. They are not driven by an incoming flow of energy. They are built into the structure of the fields themselves. This means that even in the absence of everything we normally associate with energy, there is still motion, still change, still activity. But it is a different kind of activity. It does not form objects. It does not create visible patterns. It does not stand out. It exists as a kind of background motion, a quiet restlessness that never fully settles. And this changes the meaning of disappearance once again. Because if energy is still present even in empty space, then the idea that energy goes somewhere else when it disappears becomes even less convincing. There is no outside for it to leave to. There is no region of true nothingness where it can escape. Instead, what we call disappearance is always happening within a universe that remains filled with structure at every level. Even in its quietest state, reality does not go silent. It only becomes subtle. And once that is clear, the question shifts again. Because if energy never truly vanishes, and even emptiness contains a kind of activity, then what does it really mean to say that energy was ever there in the first place? Up to this point, the question has been simple. Where does energy go when it disappears? But slowly, almost without noticing, that question has begun to change. Because if energy never truly leaves, if it never actually travels as a substance, if it remains present even in the quietest states of reality, then something deeper is being revealed. The problem may not be where energy goes. The problem may be how we imagine it in the first place. From the beginning, it is natural to think of energy as a kind of thing, something that exists on its own, something that can move, be stored, be transferred, or be lost. We speak about it that way constantly. We say, energy flows, energy is carried, energy is used up. But all of those descriptions rely on a quiet assumption. That energy exists as something separate from the systems it describes. And as we've seen, that assumption becomes harder to maintain the closer we look. Because energy never appears by itself. You never encounter energy in isolation. You only ever encounter systems that have energy. A moving object, a warm surface, a beam of light, a vibrating field. In each case, energy is not something you can separate from the system and examine on its own. It is always tied to a state, to a configuration, to a way in which something exists and changes. This leads to a subtle but important shift. Energy is not a substance inside reality. It is a way of describing how reality behaves. It tells us how much change is possible, how systems evolve over time, how motion, interaction, and transformation are constrained. In that sense, energy is closer to a rule than a thing. A rule that never breaks. A rule that keeps track of change without ever becoming an object itself. And this explains why the idea of disappearance feels so confusing. Because we are trying to follow something that was never a separate entity to begin with. We are trying to track energy as if it were an object moving through space, when in reality, it is a property of the entire system, shifting as the system changes. So when a cup of tea cools, energy does not leave the cup as a thing. The system simply changes. When a moving object stops, energy is not removed. The pattern of motion is rearranged. When light fades, energy does not vanish. The interactions that defined it transform into something else. At no point is there a piece of energy traveling from one place to another in the way we imagine. There is only a continuous evolution of the system as a whole. And once this becomes clear, the original question begins to dissolve. Because asking where energy goes when it disappears is a bit like asking where temperature goes when something cools, or where motion goes when something stops. These are not things that travel. They are descriptions of change. And energy, at its deepest level, belongs to that same category. Even in the quietest situations, even in places that seem completely still, energy is never truly at rest in the way we instinctively imagine. Stillness, as we experience it, is not the absence of activity. It is something softer than that, something more subtle. It is a balance, a state where changes continue to occur, but in such a uniform and evenly distributed way that nothing stands out enough for us to notice. And because nothing stands out, the mind interprets that condition as stillness, as calm, as the absence of motion. But beneath that calm, something continuous is always happening. At every level of reality, motion persists. Molecules vibrate, fields fluctuate, interactions unfold in ways that do not pause or settle into perfect silence. Even when a system appears completely stable, completely unchanged from one moment to the next, it is not frozen. It is active in a way that does not produce visible difference. And that distinction is essential because it reveals that energy does not need to create noticeable effects in order to exist. This becomes even clearer when we consider the idea of a lowest possible energy state. It might seem natural to imagine that if enough energy is removed from a system, it could eventually reach a point where nothing remains. A perfect stillness, a complete absence of motion. But physics does not allow this. There is always a minimum level of activity that cannot be eliminated. Not because something is continuously adding energy, but because the structure of reality itself does not permit perfect stillness to exist. Even in what we call empty space, even in the absence of particles and radiation, there is still motion. Fields continue to fluctuate, not in dramatic or noticeable ways, but in small, constant, unavoidable ways. This motion is not driven by an external source. It is not the result of energy flowing in from somewhere else. It is built into the nature of the system, a baseline level of activity that cannot be removed, no matter how quiet the environment becomes. And this changes how we think about rest. Rest is not the absence of energy. It is the absence of contrast. It is the condition where energy is arranged in such a way that no part of the system stands out from another. No gradients, no clear direction, no visible structure. The system is still full of activity, but that activity has become uniform, evenly distributed, balanced to the point where it no longer produces anything we can easily detect. This is why something can feel completely still, even though it is not. Why a room at equilibrium feels quiet, even though countless interactions are happening within it. Why empty space feels like nothing, even though it is filled with underlying activity that never fully settles. Energy never truly sits still. It only becomes quiet enough that we stop noticing it. And once that becomes clear, the idea that energy could ever completely disappear begins to lose its meaning, because disappearance would require a kind of stillness that the universe itself does not allow. There is a quiet gap between what is actually present in the universe and what we are able to notice. A gap so natural, so familiar, that we rarely question it. We tend to assume that what we perceive is a reliable reflection of what exists, that if something is not visible, not measurable in an obvious way, not producing a clear effect, then it is simply not there. But again and again, physics reveals that this assumption does not hold. What is present and what is perceived are not the same thing. Energy moves directly through this gap. It can be fully present within a system, fully accounted for, still obeying every law that governs it, and yet become completely absent from our experience. Not because it has disappeared, but because it no longer produces the kind of differences that our senses depend on. Because perception is built on contrast, on imbalance, on change that stands out against a background. Without those features, the mind has nothing to lock onto. And so, even though the system remains active, it feels empty. This becomes especially clear when a system reaches equilibrium. At that point, energy has spread itself so evenly that no region differs meaningfully from another. The same temperature, the same distribution, the same level of activity everywhere. From the outside, it appears calm, almost lifeless. But within that calm, countless microscopic processes continue uninterrupted. Molecules collide, fields fluctuate, energy exchanges take place at scales far below direct perception. Nothing has stopped. Nothing has vanished. The system has simply lost the patterns that made it noticeable. And this is where disappearance takes on a different meaning. It is not something that happens to energy. It is something that happens to our ability to detect it. A shift not in reality itself, but in how that reality presents itself to us. When energy is structured, when it forms gradients and concentrated patterns, it becomes visible, it stands out, it creates effects that can be felt and measured. But when that structure dissolves, when everything becomes evenly distributed, energy does not leave, it blends in. It becomes part of the background. And the background is something we almost never see. We look for edges, for movement, for change. We look for things that differ from their surroundings. But when everything becomes the surroundings, when no part of the system distinguishes itself, the mind interprets that as absence, as if something has been removed, as if the energy that once existed has gone somewhere else. But nothing has gone anywhere. The system is still complete. The energy is still there, woven into every part of it, present in a way that no longer announces itself. And this is what makes the illusion so convincing. Because from the perspective of experience, disappearance feels real. It feels like something has been lost. But from the perspective of physics, nothing has changed in that fundamental way. Only the structure has changed. Only the patterns have dissolved. And once that becomes clear, the question we started with begins to shift again. Because asking where energy goes when it disappears assumes that disappearance is something real, something physical, something happening to the energy itself. But what if it isn't? What if disappearance is simply the moment where energy stops being something we can distinguish and becomes something that is everywhere at once? If energy is tied to change, and change is what gives time its direction, then a quiet question begins to emerge. What happens to time when change itself begins to fade? Not completely, not in an absolute sense, but to the point where nothing noticeable is happening anymore, where differences have dissolved, where energy is evenly distributed, where no clear transformation stands out from one moment to the next. In that kind of system, something subtle shifts in how time is experienced, and perhaps even in what we mean by time at all. In everyday life, we feel time through events, through movement, through transitions, through the difference between what was and what is now. A sound begins and ends. A shadow moves across a surface. A thought forms and fades. These changes give time, its texture, its sense of flow, its direction. Without them, time becomes difficult to grasp, not because it stops, but because it loses the markers that make it noticeable. Imagine a system that has reached complete equilibrium, every part identical in energy, every process balanced, every fluctuation matched by another. On a microscopic level, activity continues, but on any scale we can perceive, nothing changes in a meaningful way. No gradients form, no structures emerge, no differences grow or shrink. From the inside, such a system would feel completely still. In that situation, asking how much time has passed becomes strangely difficult. Not because time has ceased to exist, but because nothing within the system records its passage in a way that can be distinguished. Without change, there are no reference points, no sequence of events, no clear separation between before and after. Time is still there in the mathematical sense, still part of the structure of reality, but its presence becomes almost abstract, almost unrecognizable. This suggests something subtle but important. Time, as we experience it, is not just a background dimension that flows independently of everything else. It is deeply connected to the way energy is arranged and how that arrangement evolves. When energy creates change, time becomes visible. When energy settles into uniformity, time becomes quiet. And this brings us back to the idea of disappearance in a new light. Because when energy spreads out and loses its structure, it does not only become harder to detect, it also reduces the system's ability to create new, noticeable moments. The system continues, but it no longer produces events that stand apart from one another. It becomes a kind of steady background, where everything that happens is indistinguishable from everything else. From our perspective, that feels like stillness. But from a deeper perspective, it is something more unusual. It is a state where both energy and time remain fully present, but no longer express themselves in ways we can easily recognize. And once you begin to see that connection, the original question shifts one final time. Because if energy does not disappear and time does not stop, even in the quietest possible state, then what we are really asking is not where energy goes or whether it exists. We are asking why it ever becomes visible at all. Up to this point, energy has been slowly dissolving as a thing. It no longer sits inside objects. It no longer travels like a substance. It does not disappear, and it does not arrive. It spreads, it rearranges, it becomes uniform, and eventually, it becomes indistinguishable from the background of reality itself. So a new question naturally takes its place. If energy so easily blends into everything, if it so often becomes invisible, then why does it ever appear as something noticeable at all? Why does energy sometimes stand out so clearly, so sharply, so undeniably? Why does it take the form of light, of heat, of motion, instead of always remaining hidden in that quiet, uniform state? The answer begins with imbalance. Energy becomes visible when it is not evenly distributed. When it is concentrated, structured, and organized in a way that creates differences within a system. These differences form gradients, and gradients create direction. They allow change to occur in ways that stand out, in ways that produce clear effects that can be seen, felt, or measured. A beam of light is visible because it carries energy in a highly organized form. A flame feels warm because energy is concentrated in a small region. A moving object is noticeable because its energy is structured as motion in a specific direction. In each case, energy is not just present. It is arranged in a way that creates contrast. And contrast is what makes energy visible. Without contrast, energy blends into the background. It becomes part of the uniform activity that defines the system as a whole. But with contrast, energy separates itself from that background. It creates edges, boundaries, differences that the mind can detect. This is why energy often appears suddenly. Not because it was created in that moment, but because it has become structured in a new way. A way that produces noticeable change. A way that stands out against its surroundings. And this also explains why energy seems to disappear again. Because as that structure dissolves, as the gradients fade and the differences even out, energy returns to a state where it no longer produces contrast. It becomes part of the background once more. So energy does not move in and out of existence. It moves in and out of visibility, not by traveling, but by changing its arrangement, from structured to unstructured, from concentrated to dispersed, from noticeable to invisible. And once this becomes clear, something deeper settles into place, because it suggests that what we call energy is not just about how much there is, but about how it is organized within reality itself. And that leads to one final layer. Because if energy is not a thing, but a pattern of possibility, of change, of structure, then what we are really asking is not where energy goes, but what role it plays in the universe as a whole. By now, energy has slipped away from every simple definition we tried to give it. It is not a substance. It is not something you can isolate. It is not something that exists on its own, separate from everything else. And yet, it remains everywhere. Not as an object, but as something more subtle. Something that does not sit inside reality, but runs through it. Something that does not behave like a building block, but like a rule that everything else follows. Energy begins to look less like a thing, and more like the structure of how change is allowed to happen at all. Because every system, no matter how simple or complex, is defined by the ways it can evolve, by the transitions it can undergo, the interactions it can have, the states it can move between. And energy is what keeps track of those possibilities. It defines which changes are accessible, which are forbidden, and how systems move from one configuration to another. In this sense, energy is not added to a system. It is inseparable from what the system is. A particle is not something that has energy. A field is not something that contains energy. Instead, their very existence is defined by the energy associated with them, by the way they are allowed to behave, the way they can change, the way they interact with everything around them. This is why energy is conserved, not because it is a substance that must be protected, but because the rules that govern change are consistent, because the structure of reality does not break, because every transformation must balance, not in terms of objects moving around, but in terms of the possibilities available to the system before and after. Nothing is lost. Nothing appears from nowhere. The structure simply evolves. And energy is the language that keeps that evolution coherent. Once you see it this way, the idea of energy disappearing becomes almost impossible, because there is nothing to disappear. There is no separate entity to leave or arrive. There is only a continuous unfolding of states, each one connected to the next through the same underlying rules. Energy does not travel through reality. It defines how reality moves through itself. At the beginning of this journey, the question seemed simple. Where does energy go when it disappears? But now, after following it through motion, heat, light, equilibrium, emptiness, and time itself, the question feels different. Because it assumes something that may not be true. It assumes that energy is something that exists in the same way objects exist, that it can be present, then absent, that it can arrive, then leave, that it can be tracked as something separate from the system it belongs to. But what if that assumption was never quite right? What if energy was never there in the way we imagined it? Not as a thing you could point to, not as something that could be held or followed, but as something more abstract, something that only appears when we describe how a system changes, something that becomes visible when there is structure, when there is contrast, when there is motion that stands out against a background, and something that fades from view when that structure dissolves, when everything becomes uniform, when change no longer produces noticeable differences. In that sense, energy is not something that comes and goes. It is something that becomes visible and invisible depending on how reality is arranged. It is not a substance that exists independently. It is a way of describing what is possible, what is happening, and what can happen next. And this is why the idea of disappearance feels so confusing. Because we are trying to follow something that was never meant to be followed as an object. We are trying to track energy as if it were moving through space, when in reality, it is woven into the behavior of the system itself. So when energy seems to disappear, nothing has actually left. The system has simply changed. The patterns have shifted. The contrast has faded. And what remains is something quieter, something that does not stand out, something that no longer feels like a thing, even though it was never a thing to begin with. And now, as everything settles, the question that started this journey can finally soften. Where does energy go when it disappears? The answer, in the end, is quieter than expected. It doesn't go anywhere. Because it was never something that needed to travel. It was never a substance moving through space. Never a hidden material waiting to be tracked from one place to another. Instead, it was always part of the system itself, part of the way reality changes, part of the structure that allows anything to happen at all. When energy seems to disappear, nothing is lost. The patterns simply dissolve. The structure fades. The differences even out. And what remains is still there, still present, still following the same rules, but no longer standing out in a way that we can easily recognize. So maybe the real shift is not in where energy goes, but in how we choose to see it. Not as something that comes and goes, but as something that quietly underlies every change, every interaction, every moment. And as you let that idea settle, there is nothing you need to hold on to, nothing you need to solve. The universe continues exactly as it always has. Energy spreading, rearranging, becoming visible, becoming quiet, never disappearing, only changing how it appears. If you enjoy these kinds of slow, deep explorations into physics and reality, you can always come back for more on science sleep theory. But for now, let your thoughts drift. Let the questions fade, and let the quiet structure of the universe carry on without you for a while. Good night.